The vertex of the quadratic functions are basically their turning points. The way you find the vertex of part number one is you take the opposite of the term that's inside here. So that would be -2. And you leave the sign with a number that's accompanied with that particular number. So that's +5. So that's a turning point for one. Let's write that down. Turning point. Okay. For number two, so we have to look at where there's symmetry. So we see when x is -2, we get 5. And when x is -1, we also get 5. So that's not the turning point. The turning point has to be 1 point. It's in the name, turning point. See, it has to be one single point. If both points have the same y value, in other words, the same output, it's not a turning point. So 2 is clearly not it. Number 3. The turning point would be right here. That's called a turning point. Turning point. And that coordinate is associated with -2, +5. So that is -2, 5. So the only two that functions that have the same vertex would be choices 1 and 3. So making choice 3 the correct one. Okay, number 20. The domain of the function f of x is equal to x squared plus x minus 12 is which of the following? So, okay, first of all, this is a polynomial, which means that the domain ranges from -infinity all the way to +infinity. That will be true with any function. The domain will always be from -infinity to +infinity. These are the input values. That means I can put any x value here, any input, and I will get a certain output. And that's it. The domain is just what kind of inputs are you allowed to put in. You're allowed to put any input from -infinity to +infinity. Okay, question number 21. A father makes a deal with his son regarding his weekly allowance. The first year he agrees to pay his son a weekly allowance of $10. Every subsequent year the allowance is recalculated by doubling the previous year's weekly allowance and then subtracting 8. Which recursive formula? So that's important. The question is asking us the recursive formula. Could be used to calculate the son's weekly allowance in the future. So if we look at choice 1 is not recursive, so that's eliminated. Choice 2 is once again not recursive, so that's eliminated. Now choice 3. So a sub 1 is 10. So that's so far so good, because you're starting with an allowance of $10. Then it says you're doubling the previous year's weekly allowance and then subtracting 8. So first you're going to double, and then you're going to subtract 8. So we're doubling a sub n, and then we're subtracting 8. Yeah, so that one works. So choice 3 is the correct one. Okay. Question number 22. What is the solution of the inequality? So let's go ahead and solve this inequality. 4 times 2 over 5 x greater than or equal to 1/3 x plus 15. Okay. What we're going to do is we're going to multiply both the left-hand side and the right-hand side by 15. When we do that, we'll get the following. 15 times 4 gives us 60. 15 times 2 is 30. Divided by 5 gives us 6. And that would be greater than or equal to 15 divided by 3, which is 5. And then 15 times 15, which is 225. Now, all we need to do is just basically bring the x's to one side and the numbers to the other side. So we're going to subtract 5x from both sides. So we get 60 minus 11x is greater than or equal to 225. Then we subtract 60. So that cancels. So negative 11x will be greater than or equal to 285. Okay, then we divide both sides by negative 11. So that gives us x is less than or equal to negative 15. Wait, one moment. This gives us 175. 165. So this gives us x less than negative 15. Which statement is correct about the polynomial 3x squared plus 5x minus 2? It's a third degree polynomial? No. It's a third degree polynomial? No. It's a second degree polynomial with a constant term of 2? No, because it's at negative 2. It's a second degree polynomial with a leading coefficient of 3? Yep. A store manager is trying to determine if they should continue to sell a particular brand of nails to model their profit. They use the function p of n, where n is the number of boxes of these nails sold in a day. A reasonable domain for this function would be, so non-negative numbers, non-negative integers.